Any thoughts of safety for the service techs? You have more components and very high pressure. So there are some safety considerations. The first one that I saw, well, I'll say first that I haven't personally experienced. I've been to dozens of the sites running these. I've never experienced a pressure event other than sometimes you hear a relief valve chatter. You have a service valve that wasn't open, something like that, but that doesn't actually get on the service techs. That discharges into the relief header, which will be piped to outside the store. I have been on sites where had a vibrating compressor that cracked a discharge line. So you see kind of a little bit of a fog in the area. But safety wise, the only thing I've really seen that was dangerous was I saw a technician looking for a leak with his hand. And I personally feel like that's dangerous because if you're on the discharge side of the system, that could be 1,400 pounds, and even a little pinhole, it's going to be a lot stronger than your skin. So I would highly recommend not looking for leaks with your hand on a CO2 system. Worst case, if you want to use that method, get a piece of cardboard and use that because you don't mind if it gets cut. Past that, I haven't seen any safety concerns as far as things rupturing and getting on technicians. What are the symptoms of low refrigerant level and how is refrigerant level monitored? That's a great question. So you actually, most of the manufacturers will put both a high level switch and a low level switch because both conditions are bad. If you hit the high level switch, you got too much liquid in the system. You may have some variance in the system based on having reclaimed devices like that. The low level switch is important because if you're not sending liquid to the evaporators, you're not removing heat. The symptom would be is you're struggling with cases making temperature. You don't have enough liquid in the system. You can't pull everything down. So you would see temperatures rising. You should have gotten an alarm for that, by the way, based off the low level switch. And if you'll remember from earlier, we just charged the flash tank to above the bottom sight glass, and that puts you maybe 10 or 15% up the flash tank away from the low level switch. But yeah, if you went completely dry, you're just going to stop cooling and have high temperature alarms. And if the system is completely empty, how do you get it above 100 pounds? And this would be in reference to, say, system charging or service work where you had to pull a vacuum on the system. So CO2 comes in two cylinders. You can get a vapor tank, which has no liquid in it, and then you can get a liquid cylinder that's stacked with liquid, and the takeoff is a siphon tube that goes to the bottom of the tank. If you had a system below 100 pounds, you would use a vapor tank to charge it above that. And again, you'd want to make sure valves are open throughout the entire system. Everything you evacuated needs to be accessible all the way back to the charging port. And you would use a vapor tank to get it above 100 pounds and then resume charging with liquid. Can you use Modbus on the VLT drive instead of analog signal? I believe the answer to that is yes. We typically use 0 to 10 volt kind of as our default. We don't want to lock people into Modbus like you have to use our product. We want you to, and our products are wonderful and amazing. They bring me happiness. But should you choose to use our competitor, we'd like to make that easy for you. We typically default to a voltage signal. Why is stepper valve required before the flash tank? So the valve before the flash tank, we call that the high pressure valve. It's basically, if you look at the refrigeration cycle on a pH diagram, when you're above 87 degrees, you're in what's called a supercritical fluid region. That can't change state anymore. You can't boil it or condense it to do work with it in latent heat. So we go across that high pressure valve. It's really like an expansion valve to reduce us down to flash tank pressure, which during that process, flash off some gas while cooling down the remaining refrigerant to have a supply of liquid in the flash tank. If the pressure relief valve stopped from opening, if the controller can't get control of the high side of the system, what stops it from opening if the sensors are swapped? So the answer to that question is really no. So the good thing about there's a good and a bad side to a pressure relief valve. The good thing is it doesn't care about the controller. It's a mechanical device, and if it exceeds the pressure it's rated for, it's venting your refrigerant. So that's kind of a bad thing because we don't have control of it, but it's good because it doesn't rely on anyone's controller. It's going to protect the system. You want it to do that because you don't want to rupture piping. You don't want to hope it didn't hurt other components. A good side of it, though, is that most of them burp. They don't just open and discharge all of your charge. They blow off just enough to where the pressure on the incoming side of the pressure relief is below its set point. So you'll hear a chatter. It almost sounds like a child's little rattler machine gun toy. you'll hear a chatter like that. That means the relief valve is burping. And even if you have to add charge later on a hot day during a startup because you had those sensors swapped, you won't lose the entire charge. You'll just burp charge until you find the problem, and then you would recharge to get it back up to above your bottom sight glass. Can the fans and high pressure valve fight each other? So that's a great question, and the answer is actually no. If you'll remember back, let me see if I can bring this up. So the question was, can the high pressure valve and the condenser fans fight each other? So if you'll remember, what we're doing is TD control between the ambient sensor and the gas cooler outlet sensor. So the actual fan speed control, it doesn't talk to the high pressure valve, doesn't care about it. Its only purpose in life is that whatever this ambient temperature is, I want to make my outlet temperature no more than 5 degrees above ambient. And it does that at all times. On the high pressure valve side of that, if we look back at how it controls, it doesn't really care about the delta between these two. So if we look back at the high pressure valve, remember the gas cooler fans, all they care about is the difference between these two. And then the high pressure valve, all it's really trying to do is make this temperature land on our maximum COP line that we saw earlier. So they are connected in the sense that what the fans are doing has an impact on the outlet temp from the gas cooler, but they don't necessarily fight each other. The high pressure valve would react as this moves to try and bring it back to that line. So there's never a chatter, which I think might have been the intent of the question. What leak detector do you recommend for leak checking CO2? So we actually have, so this is our DGS gas sensor. It's basically our CO2 sensor. Typically, you're going to have one mounted low on any refrigeration system. So as a Danfoss employee, I would recommend this gas sensor. If you're looking for leak detection that's permanent, if you're looking for a wand leak detector that you walk around and sniff the system with, I'll be honest, I'm not familiar with the different categories. The only times I've done that, I borrow it from the contractor. So my recommendation is borrow it from your friend. Do you always want the gas cooler operating in the transcritical zone? So the answer to that is really no. It operating in the transcritical zone is based on ambient temperature. So if you picture inside the gas cooler, I've thrown out the number of 87 degrees several times because that's the actual critical point, but that's not really ambient. 82 degrees ambient would be your critical point if you're going to have the outlet of the gas cooler be 5 degrees higher. So at 82 degrees, you're really 87 inside the gas cooler. If the ambient gets below that, then you're going to be below the critical point and operating in subcritical. So it transitions between the two throughout the year, even on a summer day when you're 96 degrees at lunchtime, you're 72 degrees at night, you were transcritical at lunchtime and you're subcritical that night. Are sites using CO2 keeping additional refrigerant on site? The availability? Yes, they are. So it's asking about quantities. One thing I'll note on that I wasn't aware of till recently is the cylinder providers, air gas and such, they do charge a storage fee for you having their cylinder over long periods of time. So, especially people that are new with CO2, it's new, it's different, it must be spooky. They'll get an additional charge to keep on site like in perpetuity. But there is a cost to that. I don't know the dollar amount per cylinder. I think I heard the number of $30 or $40. But if you times that times 15 cylinders times 3 systems times 12 months, not financially viable to keep them around long term like that. Is 744 considered refrigerant grade CO2? So 744 is actually the identifier for the refrigerant itself. So carbon dioxide, its identifier is R744. I'm glad someone asked this because there are different grades. I believe the minimum grade that you would use, and this is based on compressor manufacturers, valve manufacturers across the board, is what they call Coleman grade. So you want to have a minimum of Coleman grade quality in the CO2, and it's the percentage. They'll refine it and extract it. You might get lesser percentages for something like cleaning vegetables in an industrial application. But for refrigeration systems, you don't want to have any non-condensables. You're going to want Coleman grade or better.